Oops! So I touched the soldering iron on the neutral, which the main switch wasn't even on, so the mains was turned off anyway, but it was still plugged in. And I guess there's just a slight ground potential difference between my soldering iron ground and the mains ground, because as I touched it, it just tripped the breaker. No current was drawn or anything. There's no voltage there, but obviously there must be a bit of voltage on the soldering iron ground that's a slight different potential to the neutral or the mains ground, and the RCD was like, yeah, nope. Let's do something we're a bit more familiar with. What's going on, Donnell? Oh wow, that's an interesting colour scheme we haven't seen before from the camera glitch. That's actually pretty sick. I don't mind that. It's like some 80s retro wave. Desde Argentina, yo! Don't cry for me, Argentina. This colours is unintentional, by the way. So this is a DLS Ultimate A5, I think. Is this an A5? Yeah, A5. Apparently the issue with this is that there's no sound on channel 2, I think it is. It's probably just dodgy preamp switches, but we're just going to pop the back anyway and have a little look inside, just see what this is all about. So what we got in here then? Lovely Class AB, very flashy layout, like very flashy kind of colours and stuff. So it looks visually quite cool. Not the kind of sound really that you want the PCB to be making. Means that it's wobbling. Yeah, see that flex? That's not the best. Could do with having a screw there. Anyway, yes. What was the issue with this one then? The customer said, is the color defect in the camera? It's to do with the HDMI handshake. With this capture card, it's pretty cheap capture card. So if I unplug it and plug it back in, you'll see that it clears itself up. Unplug, plug it back in, and now it's fine. Usually it just goes green, but that was a pretty cool set of colours there, the purple there. So the issue with this then is left speaker channel no sound. Okay, well, let's just confirm that that's the case by powering it up and having a look. Okay, RCA. So left channel, no sound. Signal inputs, front left. And power supply on. Signal generator on. And we're going to go with, yeah, 260 Hertz is fine to start with. Let's go down to minus 20 dB and then increase it if needed. Not going to touch any of the controls on it just yet. We're literally just going to power it up and see what it does, and then it's most likely just dodgy contacts on the switches, but we'll see. Okay, we have a blue light, we have 0.7 amps idle current draw, and we actually do have output. We actually do have output. Not very much. We have 2.7 volts RMS worth of output on the left hand channel. If we go along to the right hand channel now, let's have a look and see what that does. 2.6, yeah, that's pretty much the same. So we do in fact have output all the way up to clipping. So let's see whether it kind of drops in and out as we fiddle with some of these switches. No, that's nice and steady on that one. Subsonic, that's not for that, that's for the sub channel. Level is fine. So this one is a no fault found because it does in fact have output. One thing which it could be though is it could have a sine wave, but it could be that the ground is bad on this one, which would mean that we see a sine wave but a speaker doesn't actually play anything. So I can just connect up a tiny little test speaker just here, for instance. And make sure that it does in fact make sound. Yeah, so these were very closely, these were designed very closely to the Genesis amplifiers, which are very nice amplifiers. So yes, these are pretty nice. Power up. Helps if I plug the RCA in. Yep, well that's definitely working. Okay, well let's just check all the other channels. So we know that the right channel is working as well. I actually would like a new thermal camera as well, so I might take that recommendation from Michael there. Infrared P2 Pro. I would like to have that. My thermal imaging camera is very rubbish basically. It's super low resolution. The alignment between the camera and the thermal side is very poor. Let's go into the sub channel now. Let's turn the frequency down to sort of 30 Hertz. Let's just make sure we have output on the sub channel as well. Yep, sub channel's working fine, so no fault found. Lovely. The P2 Pro doesn't even have a visible light camera, but the thermal resolution is good enough that you can easily tell what you're looking at. That's exactly what I would quite like. Yeah, because obviously having two cameras is always going to be an alignment that's going to be off depending on how far the distance is. I would much rather just have the thermal one that you, but have it be high enough resolution that you can see. Yeah, by all means, I'd love to see some photos or videos taken with that one, so shoot them over to my Bearvids Facebook page if you like. So, there was nothing wrong with this one. One more screw. So I'll have to go downstairs and grab another amp from the to-do list downstairs. You have to bear with me while I go and grab another amp to look at. Yeah, sorry, I always forget that I unplug my mic here. So here we have an Earthquake amplifier. Just plug my main mic back in. So here we have Earthquake Mini D3000.4. Let's see what's going on here. Apparently this one's in Protect. So here we have what looks like, well, we've got 4 channels here of class D, because we've got 4 big inductors. I've got 2 relays there. This has definitely been worked on before. Wow, this has definitely been worked on before in the power supply side. Have a look at this. So we've got some definite evidence of soldering. We've got new power supply drivers in there at some point by the looks of things, perhaps. Now, what do we have over here? We've got driver boards. We've got IR 20124S. I have worked with those before. We've got 4 of these, so each pair of channels has its own driver card by the looks of things. This has been worked on before as well. This is a bit of a mess. That's got some glue on it, just making sure that wasn't like blown chip. These diodes are like very poorly soldered back on. Okay, lovely jubbly. Looks like got some kind of condensation residue all on here. So I'm just going to take some isopropyl and give this a clean up. This kind of looks a bit crusty, which can trip things into protective voltages are floating around where they shouldn't be. Okay. These boards are also kind of floating a bit strange. So this is in Protect apparently. Haven't powered it up yet to check, but we're going to have a look and see whether any of the output FETs are reading a dead short here. So let's put it on the hat cam. Okay, well, we've got dead FETs there, perhaps. Dead short there. And 211 there. And dead. Okay. So 1 channel has gone down. I wonder if it took out the driver. I don't know if I've got any of these 20124S or whatever drivers they are. They're a bit unusual. Don't come across those particularly often. So what are these output FETs? These are IRF 540N. And we have 2 very different batches in here, which is lovely. Let's just check that the other ones are the same FETs, because I have a sneaky suspicion this has been worked on before and has got... I just want to make sure that these using the same FETs across all 4 channels. Yeah, we've got 540s, different batch there again. Not always a problem as such, but it's a bit janky. Okay. Okie dokie. Let's cut these out, because we're definitely going to need to replace them anyway. And let's just have a quick check of the driver with the multimeter, which you can do. So we can take a channel that doesn't appear to be blown. We can go across the gate and source. So we have 891 and about 1600. So let's check on this one. 1900. 784. Okay, well that's a bit different. Let's check the gate resistors intact. So this one we have sort of 85 there on the meter. This one we have, yeah, about the same. About the same. So the gate resistors are intact. So we should have 2 FETs per channel. Yep. So let's just check these ones are the same as well. Flip the probes. Going to go with, so we've got a 644 and a 625. 626. 640. So we're looking for 600 and something ish. 625, 643, and now this one that's blown. Okay, we actually have wildly different values here. So I suspect the driver for this channel has failed. And let's just have a look and see what driver card that's on. Oh, yeah, we're going to need to go after the gate resistor to get a continuity reading. So we've got that one right there. Make sure it isn't also appearing somewhere else. Nope, so we have this one right here, so it's going to be this driver on this side. Yep, there we go. So that driver is probably bad because it's reading wildly different to the other one. So that's this one right here, 20 IR, what is this, IRS 20124. Go on, focus. Quite a random one that I don't often see very often, so I think we're going to remove that, and I've got some 540N so I can drop in, so that's easy. But let's have a look and see whether I've got some of these drivers. So I've got my little half bridge one here. This is a half bridge driver. Let's take these out for a minute. Now what's this? This is a, can't quite read that. Have a look underneath the IR 2156, right, so it's not that. Let's keep checking these other ones. Don't have anything new in packets just at the moment for any others, but let's just have a look at some of these. Because I might have a survivor from another amp that I just stole. That's a 20957, that's in the wrong drawer. Go in there. That's a 20956, so that's for Alpines. That's the weird Alpine driver. So I definitely don't have a driver for this board. That's an Abletech, that is for Alpines as well. There's one over here. That appears to be an etched off because there's no marking on that one at all. Alright. So just to confirm then, with these we have a low side and a high side. So I just want to see what one's going to be low side and what one's going to be high side. So the low side will be connected to the speaker terminal for whatever channel it is, but we've got relays, so we're not going to be able to check it at the speaker terminal. We'll have to check it at the inductor or something like that. Seems a bit tricky. There's not really great access to all of the traces here. All right, there we go. So that's that one. So that's the low side on this channel. And then that must mean that that is the low side for one of these, maybe? Ah, okay. So I think the layout is slightly different. So it seems like we have low side as the left, and then low side as the right, and then low side as the left. So based on that, we should have low side as this pin here connecting to this one. Okay, cool, we do. And this one should be connected to rail voltage, so we should have continuity on these other ones here. Yep. Yeah, so they're mirrored layout. So good shout, someone said that in the live chat I just saw. So they are mirrored layout, but we definitely have a very wildly different reading. So if we do the probes this way around, we should have 622 on what is going to be the low side here, and 640. So that means that this one should be reading the same as this one, which is not. And this one here, 640, should be reading similar to this one, which is reading high in the sky. So let's just have a look at the driver, because the difference is on the high side. So let's just have a look and see whether we can get any shorts or anything over by the driver itself. So we've got 208 on the bootstrap diode. That's about the same. Make sure there's nothing the other way around. 580. Compare. Don't know if I can get in there. Okay, so the bootstrap diodes, we should have 214 one way round, and then the other way round should be fully open. That's pretty standard procedure for bootstrap diodes. Yeah, so that's the case on all of these. We're getting like 212 and then fully open. On this channel that had the failed FETs, we have 207 one way round, and when we flip the probes, we're getting 579, which is not what we want. So that's almost giving us almost certainty that the driver is bad. So we're just going to pull the driver and see whether that 508 reading across the bootstrap goes away. Richard says, do you have any videos on DC offset? So DC offset will be as a result of failed output transistors or MOSFETs usually. Not always, but 9 times out of 10 that's the case. If the amplifier works but it has DC offset, then that can be a drive circuit fault, or if it's a full bridge amplifier, it can just be it can just need calibrating. Mostly full bridge amplifiers will have like a calibration potentiometer for the offset. Michael says, I sent you some thermal images if you want to show them. Yeah, I'll pull up my phone in a minute and have a look. Oh, no wonder this wasn't working, because my mains breaker tripped my, it reset my temperatures. So I was trying to desolder this at 100 degrees Celsius. Obviously that's not going to work. So we should have, okay, yeah, obviously that's going to be nice and low because we just cooked the absolute balls out of it. Let's just wait for that to cool down a bit. And while we do that, let's have a look at the thermal pictures. Just real quick, somebody on my Facebook Messenger asked me what are my thoughts about DSPs in general. Which is an interesting question, so I'm just going to kind of go back to that, and you can hear my answer on here. DSPs are one of the best things to come into the audio scene, full stop. but you have to know how to use them, full stop. DSPs don't do anything by themselves, full stop. Think of them like an aftermarket ECU. By itself it can't run the engine, comma, but fitted with the correct map by an experienced tuner, comma, then you can extract the absolute most from whatever engine you're running it on, full stop. The same thing applies to an audio system, full stop. A DSP by itself won't do anything at all, full stop. The effectiveness of a DSP comes down entirely to the skills of whoever is setting it up, full stop. It is just a tool that allows you to extract the absolute most from the setup that you have. That's my answer to that. Oh yeah, let's have a look at some of the thermal pictures from Michael. Alright, well, that's very nice. So as you can see, like, the thermal resolution is so high that you can see the numbers on the chip. You can see individual areas of hotness. 125 degrees Celsius, my friend. That is not okay. That is definitely not okay. Yo, that's sick. I need this. I need this immediately. Yes, I will be purchasing one of those. How much do they cost and what are they called? Yeah, I need one of those. I've got a new Bearvidge Clips channel that I'm putting some of the best clips from my live streams on, and someone's just said, so do I recommend Salt amplifiers, Sundown Salt amps? Looks like I don't recommend them. I don't say that they're bad, but I don't recommend them. Someone's feelings got hurt there. Okay, so this should have cooled down a little bit now. So let's just get our readings again across here. So 180, so it's still a bit warm. Let's just cool this off a little bit more with some isopropyl and then blow it. So it evaporates. 198, so we shouldn't have anything the other way around. Ah, we do. Okay. We shouldn't have anything this way round. I wonder if the diode's bad. Let's pop the diode off the board. And read it out of circuit. Infrared P2 Pro, 250 euros or so. Okay. There we go. So I think the only issues with DSPs stem from people not knowing how to use them, or people buying DSPs when they really don't need them. Passive crossovers that are designed for the speakers that they came with, for the most part, are absolutely fine. Even on substage? What does he mean? Even on so after the reply, what do you mean even on substage? I definitely wouldn't recommend a DSP just for the subwoofer, comma, that is a complete waste of time. DSPs are great for calibrating and setting up an entire system and will have the best effect on the front stage, mids and highs. Yeah, it's pretty much pointless for subs, full stop. Most subwoofer amplifiers will have crossovers built in, comma, and whatever head unit you're using as well will have a crossover built in, comma, which will be ample for setting up your substage, full stop. To get the frequencies, no, not to get the waveforms in line from the subwoofer to the next speaker up, for example your door speakers or some kind of mid-bass drivers, comma, then some head units will have time alignment which you can use, comma, but a lot of subwoofer amplifiers will have a phase adjustment which, although you can't align the waveforms exactly by where they start, comma, you can bring them in phase, which is more than enough for a subwoofer application. Most sub. Obviously, if you are using a DSP to calibrate and set up your front stage, etc. already, comma, then having the flexibility to tune the sub on that same DSP is great as well, comma, you might as well, full stop. But buying a DSP just for a subwoofer stage is incorrect. My opinion. My opinion. Make sure you get the Pro version with the macro lens. Okay, I'll check it out. Thank you very much, Michael. I appreciate it. So with that diode out of circuit then, let's have a read across the board once more. Nothing there. Nothing there. Okay, so it must be the diode then. .687 and nothing. Huh? Where has the low number gone now? All right, so we're black probe on the line. Okay, 200. And okay, yeah, there we go. It just wasn't reading correctly. So yeah, this diode is toasted. And this is an SS36. We don't have to use the exact same diode as that. We could use a ES1D or something like that. It's just going to be used as a bootstrap pump. That's fine. So we probably do need a new driver though. So yeah, IR. Let's have a look and see if we can find this on the internet. IR 20124S. So let's see, can we find this on the internet? IRS 20124. No. RS does not have this. Does Farnell, does Mercatio, Mouser, maybe? eBay. I'd rather not, if I can avoid. Amazon. UT Source. Not had great experiences with UT Source recently. Someone in 2006 had 54 pieces of the 20124. I wonder if he still has them. ¿Por qué es en español? Necesito en inglés, por favor. Much better, right. ¿Dónde? So I can get them from UT Source. I'd rather not. By any chance, does it have the same pinout as like one of the more modern ones? In OC set, nah. That's wildly different to anything else. It looks a little similar to the 21844S. With pin 1 being input and low output being 7, I think it is. Oh no, this is different. Yeah, no, low output is 6 on that one. I don't think that is the same as any other ones. Let's just check the pin out of this. Oh wait. No, this looks different. That's different. Oh, comparison. Oh, the 4 is the old version of the 7, so that's going to be the same layout then, isn't it, as the 4? Yeah, nah. Nope. So it's going to have to be probably an eBay jobbo and just hope that they work. And if they don't, I can send them back. £10! What? No thanks. We shall not be spending £10 on one chip. It might have to be a UT Source job. Damn, £12 is the cheapest on eBay. Can we have 5 of them from Wang, what was this? Wan Heng Lee Electronics Co. Shipping. Okay, so the shipping is going to cost me 11. I'll change this to GBP, please. That would be good. So I can have 5 of them. I don't know my login details. I can't remember what they are, and I usually use Chrome. So I can get 5 of them for probably like 25 quid. All right. Well, we could power it up and just see whether the rest of the 3 channels work, couldn't we? So we just see whether the other 3 channels work. This is like an older style drive, so I suspect that the remaining channels will work fine, even though that one is, the driver is removed. I don't think the protection circuit's going to care about that. No, do not sundown SFB. Yeah. Do not sundown SFB. 600 watts at 1 ohm, bro. You will have literally hundreds of good options on the second-hand market. Alpine PDX, MRV, MRP, something like that. JL Audio 600/500/ fucking. Oh man, you got so many options for like a 600 watt, 500 watt, 600 watt, even 1000 watt used amplifier. You can even go class AB if you don't care about the efficiency. Right, mic's clipping again. What I'm going to do is I'm going to turn the microphone down and I want you to tell me if the clipping sound still remains even when the volume's low, because that tells me it's clipping before OBS. Are we clipping? So did you still have the clip sound even though it was less quiet, or was it not clipping? Because that tells me that the clipping is actually happening inside the camera rather than in OBS. Okay, so the clipping is nothing to do with OBS. The clipping is something to do with the actual camera mic itself. So let me see if there's a solution for that. Audio input capture 3 minus 1.2. Okay, that's just changing that. Sync offset. So let me try in Windows. 1 2 1 2. There we go. Levels. Okay. So we're a bit lower now. A bit lower still. 70, 75. Go 75%. Are we clipping? D. Hello. Are we clipping or not anymore? One, two, 1 2. Still clipping. Nope. Yes, nope. Make your mind up. Is it the clipping anymore? I don't know. Better than before. Okay, I think we just maybe need less. Even less. Doopy doopy doop. Alright, so we're now at 60. 1 2. 1 2. I can't reach the red bars anymore, so. Are we still clipping? When I shout loudly. Okay, yeah, it must be something in the actual mic itself. I'm gonna go down to like 70, 73. That should just keep it nice, you know, about 75. That should keep it alright for most people. I don't know if there's any extra settings on here. Advanced. Change it to tape recorder quality. How 1 2. How's about that? How does that sound? How's that quality for you? Tape recorder quality, bro. You love to see it. Does that sound really bad? Alright, we're back up at DVD quality now. Yeah, not much else we can do, I don't think. So I'll just have to try not to shout. Alright, so do the other channels work, even though that one's removed? Let's just go to zoom out a little bit here. Bit more voltage than 9. Okay. Ah, what do you know? The fuses have pop head. The fuses have pooped. Pooped the fuse. So this needs, oh, it doesn't say what it needs, but they were purple before, but let's just put a couple of 40s in. The best sound I ever had on live stream from the microphones was when I had my RTA mics hooked up. What is wrong with this? This fuse is thicker than the old ones were. Yeah, when I had the RTA mics hooked up years ago, that was the best streaming sound quality. Then I started using them for boom or bust and whatever. Okay, let's try this again now then, shall we? There we go. So we have a little bit of voltage there coming up. Ooh, that's not what we want. We have positive rail on this one here. Oh no, wait, there we go. Maybe it just was weirdly unhappy with that. Let's just zoom in there. Okay, cool, looking good. So we have 1 amp idle current draw. We have 470 kilohertz Class D switching. Not bad, not too shabby, considering the age of this thing. Yeah, so the other channels work fine. And we don't have any excessive current draw or anything like that. So yeah, we just need a new drive IC. I'll have to try some from UT Source, I think. Okay. So another one to the side that we can't fix just now. Until we get some parts. Michael sent me some drive IC links on Facebook. Oh, if you prefer eBay or Ali over UT Source. So you're in the States, so I suspect your eBay links will not be compatible for me. In response to this DSP chat we were having earlier, thank you as usual. I think I'll be getting a DSP for mids and highs definitely. Yeah, I would recommend it if you are looking to go down the extreme SQ route and are dreaming about a beautiful, sharp focused sound stage and imaging, and if you want to spend more time sitting in your car changing the settings than actually listening to music. Laughing face. But bear in mind that unless you already have experience in setting up DSPs or understand what you are listening out for and looking for, then you probably won't be able to set up the DSP to improve the sound at all, and if anything it'll make it sound worse. You can pay people to tune DSPs, but it can get pretty expensive. Full stop. The best in the country would probably be Peter from PS Sound. Right, I've got another Earthquake amp downstairs to look at, and we've also got some Vibe MK21s, which I protect as well. By the way, just seeing as we have some other technicians in the stream, has anyone ever seen this mains switched mode power supply board before? Do you recognize this? So this is the switch mode power supply board out of a JBL PartyBox 1000. And these all suffer from a common issue where the kind of oscillation for the main 50 volt rail voltage, use a single positive 50 volt rail. And there's a common issue with these where it just doesn't start oscillating. You just don't get the 50 volts rail. This kind of circuit here doesn't start oscillating when it's told to. I have been through and replaced near every goddamn component on this PCB, and I cannot get it to oscillate. Sometimes it works, that's the thing. Every now and then it will come on and start oscillating. But then you turn it off, unplug it from the mains, plug it back in, turn it on again, and then it won't oscillate again for a long time. And I've replaced almost every component that you see here and checked every resistor and checked every transistor, every capacitor. All the optocouplers have been replaced, the drive IC, all the diodes, basically every semiconductor part, all these transistors, all these voltage regulators, all these resistor values have been checked all across the board here, even going back into the auxiliary supply circuit, which works fine. The main diodes and MOSFETs have also been replaced. The Zeners on the top of the PCB have been replaced. Everything has been changed. I can't find anything wrong. So I gave up and I bought a replacement one of these for about £100 just to kind of get the thing fixed and get it back to the customer. So when the new one came in, obviously I put both of them, the brand new working one and this one on the workbench at the same time, and used my multimeter to try and find any discrepancies between these two. And everything was identical. With the multimeter, just going through diode mode and resistance mode and stuff, everything was exactly the same. Nothing was showing up as being different, so I have literally no idea. So I've just got this now, and I'd love to know what the problem is, because then obviously that would help out hundreds of people that also have this same problem. But I can't. I couldn't find it. I was spending far too many hours on it. Does that model have battery power also? No, it's just a mains power, that one. Does it tick at all or just do nothing? Yeah, nothing at all. No ticking sounds, just literally nothing. Probing all of the voltages on the driver suggests that it should start oscillating. It needs some kind of weird feedback loop from this optocoupler. This optocoupler needs to kind of send a signal to pin 8 or 9, I think it is, and then it comes on. And that sort of wasn't happening, but there was nothing wrong with the optocoupler. There was nothing wrong with this circuit down here. There's a kind of feedback thing that needs to happen in order for it to come alive, and that it wasn't happening. I don't really know why. Difference with the oscilloscope. So what I didn't do is I didn't take the new one of these and power it up on the bench with the oscilloscope connected. The reason being is I didn't want to make a mistake and accidentally kill the new board. With my probe or something like that. I was very conscious that I bought a new board for £100, which is quite expensive as an electronic part goes for a technician to buy a new board. So I didn't want to risk damaging the new board by powering it up on the bench. I just literally took the new board, multimeter checks, everything was the same, fuck it, put it in the unit, screw it together, send it off. So yeah. Let me go and grab another amp from downstairs that we can look at. PCB defect? Maybe, but I couldn't see anything. It's a single-sided PCB, so very unusual to have. To probe mains voltages, you need a differential probe. Not necessarily, you don't need a differential probe. You can just have the scope floating. It's a bit risky, don't touch any grounds, but you can just float the scope and that's fine as well. Right, the other amp, the other Earthquake, is actually exactly the same. So we could, if this one has blown output section as well, we could make one working amp from two dead ones by stealing a driver, because this will be the same drive circuit, won't it? When I have both microphones on, is there an echo? Is there currently an echo? EV Blog fixed a JBL PartyBox recently. I might go and check it out. I might go and check out his video to see whether it was the same issue or not. I don't know if it would be, but boards like that, I usually see a hairline crack. You know what? You could be onto something there, Timbo, because, like I say, this PCB, it was intermittent. Sometimes it would work and sometimes it wouldn't. But I'm not sure where would there be like a hairline crack on this, and it's going to have to be like around this area. But like, yeah, I looked over it with the microscope as well. I also reflowed like a bunch of things. So based on your experience, what kind of traces would have like a hairline crack? Maybe it's just a case of taking the multimeter and like going across, just checking all the traces that lead everywhere, and making sure that they actually make continuity to where they go to. You know, oops, sorry, what's the PWM controller? The PWM controller is, I can't read it, can't remember. PWM controller is a L6566B. L6566B. Oh, corroded trace on the power button. Yeah, that's definitely not what we have here. Yeah, but not like I've already written this one off and I've given up with that one. So this is another Earthquake 4-channel, the same as that other one we were looking at. So we might be able to make one working amplifier out of two here. So this one has also been repaired in the past by the looks of things. Okay, there's our short. Not on the same channel. Oh, we got one. So this channel here, this time, different channel to before. Okay, so let's cut out these FETs, which are shorted. 55. You need to announce the lives on the Discord, bro. I can't remember to do that. Like when I go live, it's just so sporadic. It's just like, oh, I'm gonna go live now. And I also don't use Discord. Like I just can't. yeah, I just can't use any more social medias. I'm like, my brain is full up of social media things. Right, so I think the driver for this one's bad as well, because we're supposed to have like a sort of 600-ish reading, which we don't have. We have the gate resistors intact. $622, $530. Yeah, so the driver for that one is also definitely bad. So yeah, we can definitely make one working amp out of two bad ones here. So the driver for this channel is going to be, where is it? That's strange. Oh, that's because I'm on the gate there, FET side. Idiot. There we go. It's this front driver card, front driver card again. So let's remove the driver, check the bootstrap diode because that was bad on the other one as well. Any other platform you can just put a quick post? I don't know, man. YouTube should do that for you. Like, you should be able to set up notifications that I'm live. I can't guarantee that I'm going to remember to do that. Greg says, what power amplification do you be using just to see that stuff? I opened a Class D amplifier, had to close it right back up. The thing is, I learned how to repair electronics on modern Class D stuff, so that's normal to me. I look at the board and I can identify areas and sections that are all the same. It doesn't look complicated to me because I kind of know I group everything together as to where everything is. If pin 5 versus pin 3 on the PartyBox PWM controller is less than 14 volts, check the cap connected to those pins. That's basically the #1 fault on mains power supplies in general. Set it to photonic induction, yeah. I don't know what he's doing these days. Yeah, it would be great if I was brave enough to power the new one up on the bench and compare the voltages, but I just don't want to risk damaging it because it was very expensive to me. And yeah, I just want it gone because the PartyBox 1000 is currently just sitting in my kitchen taking up a massive amount of space. So I don't want to risk like having to wait any longer to get rid of it. See you later, Greg. Measuring at the cap with a multimeter should be reasonably safe. Yes, the problem is, Michael, is in order to get the power supply board up and running, you know, to actually start turning on, I need to inject voltage into the standby pin. So I've got to actually do some sort of voltage injection and stuff to make it think that the amplifier board with the power switch on it and everything is present. It's just a bit of a palaver to set up, and there's things that can go wrong. So, or just desolder the cap from the bad one, check the ESR. Okay, well yeah, we can do that. All right, let's check the bootstrap cap on this one. Well, yep, that's toast. That is a French toast. All right, so yeah, we have two of these that are dead, and we can make one working one by stealing drivers, etc., from one to the other. So I guess we choose whichever one's in better physical condition. Let's have a look at this one. What does this one look like? It's got a nice big scratch across the front. How about the other one? Well, I'd say this one's better, wouldn't you? So let's take a driver and a bootstrap cap while we're at it, just because it's right there, isn't it? It's be rude not to. Let's take a driver and a cap from this one, slam it in the other one, and fit some FETs. Okay, so that's our good driver. So let's pop that down there for a minute. Let's also nick the bootstrap. And let's solder it into this one. Bit of flux. There we go, and the bootstrap diode as well. Which way around is this going? That's going that way around. Why is the camera not wanting to focus on like the top and not what I'm actually looking at? Bro, come on, focus on what I'm actually doing. Here we go. And we just got to take these cut legs out, slap some new FETs in. Nah, this is not a Class H, this is just a Class D. this middle one obviously has a bit of thermal mass underneath the board. Okay, no worries, we'll just have to sink the MOSFET down into that one when the lick's cooking. No worries. No problemo. Alright, and this uses 540N. Excellent, I have some of those, I think. Could probably make this amplifier better by fitting some better output FETs actually. This is quite old now, this amplifier, so at the time there probably wasn't such thing as like the 4115s or various other similar MOSFETs that are fast and very high power. But it just depends whether the rest of the circuit will be able to handle the extra power from dropping the impedance lower. What have we got here then? Yes, very nice. 2 brand new 540Ns. I'll take that. Take them. There's one. There we go, there's 2. I'm just going to check the side plate on this is a bit loose. So what I want to check is that the RCA blocks don't have any snapped ground pins, because if this is being flexed around a bit, then we might have a snapped ground pin on one of these RCA blocks. So I just want to check for that, because that can cause lots of buzzing and unnecessary unwanted noise in the system. Have you ever seen an amp protect due to being too cold? So it won't be the cold necessarily that's causing it. It might be condensation residue from it being cold. I can't really think of any components that would cause it to protect from the component themselves just being cold. I mean, possibly the thermistor is going that far out of tolerance. The designers didn't take into account if thermistor goes too far in the opposite direction of resistance as well, but I doubt it. Just having a quick look at these RCA blocks, because these ones can snap the ground pins quite commonly. No, that looks okay to me. Good. Alright, so let's see whether there was any other drive circuit faults on this one. Now we've replaced the driver and the boot strap. Alright, fingers crossed. And that is going to be this one over here. The gate resistors were fine, weren't they? So oh, there we go. Yeah, perfect. Class D switching looking very nice. Let's just check the gate drive waveform on the low side. What do you look like? You look like this. A little bit rampy. But it is the same as the other channel, so yeah, no issues there. Ever so slightly higher VT on these new FETs by like point something of a volt. Just thought it was worth mentioning, seeing as I noticed it. So we were able to fix one by sacrificing and removing a driver from the other one. No problem. So I'll have a look on UT Source, maybe order some parts a bit later, because it'd be nice to get them both back up and running. Alright, so next we can either look at, I've got an old Orion, I can't remember what the model is, it's an Orion like 2000-ish watts mono subwoofer amplifier, and there's an issue with the preamp circuit. The audio isn't making its way through the preamp board to the amplifier section. I confirmed that the amplifier works by just injecting the audio directly into the amplifier section, but the actual something wrong with the preamp circuit, and it's not letting audio through. So that one I've already looked at for maybe like half an hour, and it's not something that's immediately obvious. So we could look at that together, and that might be quite a tricky one that we can look at together. Alternatively, I can look at what do I want to look at that Audison yet? I've got a Vibe M21K, which is a big Korean full bridge 10K amplifier, probably with dead output MOSFETs, which we can look at instead. I've got the DS18 version of the Vibe. Yeah, there's a few different brands that are using those boards. They are not very nice. I don't like it. Alright, let's have a look at this Orion then with the preamp fault. It is up here. Here we go. Okay, this one is a little tricky to work on because you'll see. So this is the Orion that I'm talking about. It's an XTR, I think it is. So this is the driver board for the Class D output section. We don't need that fitted, that's fine. This here is the preamplifier. As you can see, it's had quite a lot of work done to it already. It's had op amps removed and replaced previously. Same on the main board down here. This is missing. What is that? What was that? I think I removed that last time. I can't remember what it was. Shit. What did I do with that? Was it bad? Oh, I don't know. Did I put it in the screws bag? Okie dokie. So when I looked at this a couple of days ago, I removed this. But now I can't remember what it was, because it was a few days ago and I think I was planning on continuing to work on it but then didn't. It's not an 074, it's something weird and different. It could be this actually. This is a 13600 JRC A500. If that fits, it's probably that. Yeah, I think it's that. I don't know, it's quite big. I think it is that. Whatever it is, it will be something that's just on my desk here, just chilling. But I do believe it's that, so I'm just going to put that back for a minute. Now, I've got a funny feeling that the issue might actually just be a bad via with these old boards. So one thing I'm going to do first is I'm just going to go through and reflow all the vias on the main board and also on the daughter board for this preamp thing here as well. So I've got a little modification that I make to those Korean full bridges. It's just putting some 4148s in parallel across the output gate resistors. Massively reduces the idle current and the amount of heat that the output FETs generate. It's yeah, they should be there from factory, but I don't know why they weren't. Godfrey says, where do I get my tips for my soldering iron? So these are specific to AOUA. They have the heating element in the tip. I get them from a company in the UK here that sell these. Alright, so I'm just going to go through real quick. I'm just going to go through and reflow lots of vias on this board, because that's the kind of stage I'm at next that makes the most sense, I think. So I'm just going to dropping some flux on any of the vias that I see here, and then I'll just put my iron with a bit of fresh solder on the tip and reflow. The thing with vias going bad, especially in the preamp circuit, is that the voltages and currents are very, very low. So that means that if there's like a slightly poor connection, then the voltage can't overcome the bad connection and, like, you know, connect. It needs to be very, very solid in order for that to actually work. So we're going to do the same thing on this little daughter board here as well. Go through all of these vias. I have to remove the barcode so we can get to the vias underneath the barcode. Alright, let's start going through some of these vias. Now, reflowing a bad via isn't necessarily going to make it conduct again. If it's pretty screwed up inside, but a lot of the time it can at least temporarily bring one back to life, enough to show you a difference in how the amplifier is behaving. Just because the heat can expand the joint for a minute. Okay, I think I pretty much covered all the ones on this daughter board. There's maybe a couple down here that don't look so great, so just going to go over those. Okay, cool. Just going to do a little quick visual from the top, just in case anything looks a bit janky on the top vias. Like if any of them, you know, don't look like super nice. Mostly okay. There's a couple on there that aren't the best, but we're just going to roll with it for now and see what happens. So let's do the ones on the main board. Okay, I think that we could probably power it up and just see if that's made any difference. I doubt it has. I suspect there's an actual bad component somewhere, but with an older amp like this, it's absolutely, if you're getting weird issues, it's absolutely worth just going over the vias. Just takes like a couple of minutes, because sometimes they do just go bad and it can drive you nuts because you find no bad component, so it doesn't make sense. It turns out just to be a bad connection somewhere on the via, so always worth going over if you're having a bit of strange problems. All right. So that needs to go back in there. We're not going to put the I'm not going to put the Class D back in. Actually, no, should I? Should I put the Class D back in? I don't know. Maybe. No, I'm not going to put the Class D back in yet because I know that we're supposed to see sine waves on some of the input pins to the Class D board, like here and here, for example. So if we see them, then reflowing the vias just fixed our problem. If we don't, then that's probably not fixed it. So let's connect some power wires to here and go from there. Where's the pistachios? Well, they're just on the floor, but I'm not hungry just yet. I think I'm going to get a cup of tea and a cookie in a minute. Alright, so let's power this up, and what we're looking for is some little sine waves in some of these pins. And probably just make sure that solder bridges, anything like that. Right, that's fine. So we need some signal input. Wow, which is the RCA input? I can't remember. Let's have a look on the case here. Here we go. Input is here. Okay, let's do that one. And we're going to have master and full send, subsonic off, bass boost at minimum, gain up a little bit, remote, okay. Looking for sine waves, so let's change the scope settings. Project high frequency. Okay. Alright, so we've got some rail voltage. Good, so that's all up and running, amplifier's up and running, so we're looking for little sine waves around this area. Ah! Well, there's a little something there, but I think that's too low voltage. So that needs to be a lot higher in amplitude, I think. What we can do is we can fit the Class D board just to see what happens, but I think that is where the sine wave goes in, and that's far too low. That's like 100 millivolts. It needs to be more like 0.8 or something like that. So let's just wait for the rail voltage to sink back down again. So the guy that's been asking me questions about the DSP for subwoofer application, this would be an inexpensive DSP for SPL style audio setup. Would still be nice to have a decent sounding front stage considering the speakers I'm using. Yeah, for sure, comma, but again, comma, if you don't know how to tune a DSP, then it can make things worse rather than better, full stop. Doesn't matter if the setup is SQ or SPL oriented. So let's plug the Class D board back in, make sure that there's no rail voltage still sitting here. There is. We have 6 volts of rail. That should be alright. That should be okay just to plug this back in. And see what we have on the output of the amplifier then. Okay, there's our Class D. Yeah, so this is all we get on the output side. We get just this. It's like 2 volts, and then it clips in the preamp. So something in the preamp is wrong. Flicking the switches on the side doesn't change anything. Pushing the buttons in and out doesn't change anything. So yeah, there's a pretty annoying problem in the preamp. Potentiometers don't really change anything. We get a little bit more signal if we allow the low pass filter up a little bit. Increasing the gain doesn't do anything. So yeah, pretty annoying problem, and the Vias hasn't solved it. So we can try and find out where the problem is by working our way through the board. So it doesn't seem to have anything to do with the frequency. I don't believe, or maybe it does. Hang on a minute. That's an interesting one. Is the frequency response linear? Now Michael, that is actually a very good suggestion to check, because obviously with this amplifier it has a low pass filter, but if we set the low pass filter to full, now this should play full range. I don't know if it will. Low pass filter goes up to 250 Hertz, but if we set the low pass filter to full and subsonic off, then we should get pretty flat frequency response, at least up to 500 Hertz, I would have thought. So let's have a look. Let's go in here. It looked like we didn't have a flat frequency response on that little waveform. So let's start out at like 25 Hertz. Okay, so 25 Hertz we clip at 2 volts. Okay, that's where we're at. So we've got 2 volts at 25 Hertz. As I start to increase the frequency, we increase the gain a little bit. The signal is increasing slightly. We're now clipping a little bit. We haven't turned the gain up. We're now clipping a little bit on the preamp. So we're now at 2.2. Now let's keep going further. Now by the time we get to 65 Hertz, we're now on our way back down again. By the time we get to 90 Hertz, we're down at 1.8. So you can see here, this is the frequency response. So by the time we get to like 70, we're on our way down. By the time we get to 132, we're down at 1.4. So possibly there's a capacitor in line with the signal that's gone bad, which might be causing this. Heat some of the capacitors to see which one has gone bad. Very good idea again. I should stream more often. There's great suggestions coming in here, guys. I'm going to turn the temperature down on my hot air station. I'm going to probe the sine wave while heating a few different capacitors to see whether the signal level changes as I heat or not heat some of the caps. That's a very good idea. I hadn't really considered doing that, but that makes perfect sense. I'll tell you what I have done though, is I have tried heating the heating various different ICs to see whether that makes any changes, but it hasn't so far. So let's give that a go. It can't be a series cap. That would cause the inverse effect unless it's in the feedback path. Okay. Well, let's just try heating some bits and pieces anyway, just to see if that changes the amplitude of the sine wave at all at any of the frequencies. So let's power this up again. Get that locked in. So what we are looking for then is we seem to have a decrease in the waveform amplitude above here. So if I just start gently heating some of these, let's see. So we got basically 1 volt at the moment. So I'm going to just start heating various parts on the board and see if we ever change or increase from 1 volt up any higher. I don't think it's going to be anything on the Class D board, obviously. But and the issue, another annoying problem is I can't really get my my hot air gun in here because the board's like kind of upside down. Turn the pressure up a little bit. Turn the temperature up a little bit as well. Okay, I'm doing some heating, and I'm not seeing any change to the waveform. It's not getting higher or lower in amplitude as I sort of bring the hot air gun in and out of these parts anywhere, really. What I will say though is that we do get good big high amplitude sine waves. I'm just going to turn that off and let the row voltage thing down. We do get big high amplitude sine waves coming in and out of this top board. So the issue, I believe, appears to be on the bottom here, like just before it gets sent to the drive circuit. Michael said mechanically knock the board and look at the waveform. Yeah, I have tried that and it didn't do anything, but we can try again. Yeah, so no change in the waveform here. Cup of tea. If it's on the bottom board, could you potentially run it with the input board, inject a signal to the connector? Yeah, I have considered that. Problem is that there's a lot of signals going all sorts of various places. But yes, I could do that. That's probably one of the things that I will try next. Is inject the RCA signal to one of the pins coming from the main board that has the audio on it. Get to a point where we have the same behavior as with having the top board in. Therefore, I mean, you know, having this kind of low voltage on the output with it clipping on the in the signal path side, and then obviously I can have better access to the board to figure out what's going on the main board. But let's just have a cup of tea and do some Q&A, do some live chat stuff with you guys while I have my tea. Yeah, so all of the normal stuff like switches, potentiometers, all that stuff has already been tried. The op amps have been changed as well. Yeah, I've done all of the basic kind of normal stuff that would prevent full signal getting through. I believe there's a component bad somewhere. I just can't figure out where. Or a trace maybe. So I can actually bend this up slightly. I can sort of get in here. Yeah. Now fortunately these pins are doubled, so it doesn't matter if they touch each other. So I could just bend this at a 90 degrees. Problem is it's going to touch on this board here if I do that. So I do have like reasonable-ish access in there, but it's not ideal. It would be good to inject, for sure. Man does not have a landline phone. Times have changed. Just while I have my tea, let's just come back to this switch mode power supply from the JBL PartyBox. So the capacitor that some of you guys mentioned was between, what pins was it between? It was saying to check the ESR off. Pin 3 and 5. Okay, let's have a look. Which way round does this go? It goes that way round. One, two, three. And 5. So that would be this one. Little surface mount jobbo. Okay. Let's have a look at the data sheet. What's that doing? That is an L6566B. Between VCC and ground. That wouldn't stop it from working though, would it? Like, I definitely have it, the correct VCC present. I've measured 14 volts there. That cap provides power to the chip during startup. I think the 14 volts comes from an auxiliary supply. It's not kind of, I don't think it's generated by the switching, if that makes sense. I don't think that the chip's output creates the 14 volts, so therefore it needs a boost to start. I don't think that's the case, but I mean maybe. Well, I'll remove it and we'll have a look at the ESR. But I think the VCC, which is on pin 5, that comes from 1, 2, 3, 4, 5. That comes from... Where does that come from? This diode, which goes over to this area. We've got a big capacitor here. Yep, this big green capacitor here. And also to pin 7 of whatever this chip is. So the supply, the VCC for our controller comes from this chip, which is a, I don't know because it's hard to read. Let me just have a quick look. Comes from pin 7 of a No, I'm going to have to spread some thermal paste over the chip to read the numbers. I'll do that in a minute once I finish my tea. Three PC SO3. Power factor correction. Pin 7, VCC IC supply voltage. Okay, so it's not coming from there, it's being fed with it also. Okay, that's interesting. So it must go somewhere else as well then. Where else does it come from? Okay, we also have continuity VCC to this big green one, this 35 volt 47 microfarad. So maybe that's the bad one. I probably should have pulled all the caps and checked them, the ESR. I never did that. I think the problem with coming from a car audio repair kind of background is that in car audio, the issue is never the cap. Like, capacitors are extremely rare a problem in car audio application. I rarely ever come across bad caps. So therefore, when diagnosing mains, switch mode, power supply, stuff like this, where bad caps often are the problem, it doesn't sort of stand out immediately as a thing that I should check. Oh hey, wait, hang on. Okay, so we have 46 microfarads ESR 0.64. That's looking okay. It does seem to take a while though to read this cap. Like, see what I mean? Yeah, like sometimes it'll just pick it up instantly. It does seem to take a while, so it's still a little bit suspicious. Yeah, it's labelled as 47 microfarad, yeah. Yeah, delay due to large capacitance. True, but sometimes when I measure even like bigger capacitors, you know, like really massive rail caps, there isn't that much of a delay. But yeah, I agree, it does look fine, doesn't it? Do I have another one I could just replace it with anyway? Am I okay to go up on the capacitance? Can I go to like 100 microfarads and it be okay? Okay, so it's not that, but maybe should I check some of the other caps? I mean, there isn't really any other of these aluminium caps really floating around this area. So I'm not powering this up. I'm not going to power this board up because it's just going to take too long to get that set up. So I can probe it with the scope and stuff. And I don't really care anymore either because I don't have a use for it. It's just like I bought a replacement board from AliExpress already, so it was just more of a curiosity because this one really beat me. I spent hours and hours on it. But yeah, anyway, enough of that. We were looking at this Orion . And we were looking at problems with the audio, the preamp circuit. So let's plug an RCA back in and let's check what signals we have going into and out of this top daughter board, okay? Because obviously we want to inject. So let's power this up, and we want a sine wave. I'm going to find a sine wave on here. Okay, so we have I'm actually going to go into the top one because that makes more sense, I think. So we have sine wave pin. So we have, I'm going to go down from the top here. So we have sine wave on 1, 3. So sine wave on 1 and 3. These middle ones are just VCC. Sine wave on 1 and 3. Okay, so we have from the top board to the main board, we have a sine wave on 1 and 3 on both of these types of headers, actually, this top one and this bottom one. If I go into the bottom RCA here, we have a sine wave on 2 and 4 and 5. Okay, so this one we have 2, 4 and 5, 2 and 4. Okay, so 1 and 3 or 2 and 4 essentially. So if we remove this, we should be able to rule out any ones that are from the main board to the daughter board by seeing which ones still have a sine wave on them. So we were 2 and 4 on this one, so let's power up again. So no sine wave on 2, no sine wave on 4, no sine wave on 5. Okay, nothing on any of these actually. So probably this is the header that we're probably interested in. 1, 2, 3, 4, 5. Okay, well we have no sine wave anywhere. What the heck? What the heck? Is it just that my scope isn't making like a decent connection through? I think maybe this little pin isn't long enough to actually touch the pins. So if I just use one of these little component legs, that should help. Right. So nothing on 1, nothing on 2. Nothing on 3, nothing on 4, and nothing on 5. 5 seems to be NC, not connected. Okay, and let's try this one. Nothing on 1, nothing on 2, nothing on 3, nothing on 4. Huh? Where the heck is the sine wave going to the daughter board then? I am mad baffled. What? Well, that doesn't make any sense, does it? What? Two. 4, 5, 2, and 4. What the heck? Some of these sine waves have got to be coming from the bloody main board. Otherwise that makes no sense. Literally. I'm going to turn the gain up a bit. Right, nothing on 2. No, nothing on 2, nothing on 4. Nothing on 5. Nothing on 2. Absolutely nothing on 4. This doesn't make no sense. What the heck? Yeah, that really isn't making sense. How is this? I don't understand. So my signal generator is not floated. My signal generator is tied to the power supply ground. That's not sensing. Unless the VCC comes up and goes back. No, it doesn't though, does it? Really don't get that. Alright, well, fuck it, I don't care. I don't care, I'm just going to start putting these pins in 2, 4 and 5 and then touching the RCA and seeing if we can mimic the audio output problem that we get with the daughter board fitted. So I'm just trying to find a thick little jumper here to make a connection on. Check ground and VCC signal. Let's have a look. So without the daughter board we have 14 ground, 14. So yeah, the VCC supplies are all good and present regardless of whether that's fitted or not. So I'm going to go into pin 2 here. We're going to turn the signal down and I'm going to probe the amplifier output here. Okay, I'm going to fit the driver card back in, I think. Is going to be the thing to do here. Just going to wait for the rail voltage to sink down a little bit, and then we're going to inject audio to each of these pins just to see if we can mimic the behavior with the daughter board fitted, and that then allows us to probe around down here and find out where the issue is. Okay, so probe amplifier output, like that. Okay, power up. Okay, so that's creating a little bit of output on these speaker terminals. Let's go along to the next one. That was pin 2. Let's go along to pin 4 on this one. See what that one's doing. That gives us a little bit of output as well. Not lots, but a little bit. go along to the next one. I'm not injecting much RCA signal yet, you see. I'm just seeing which ones give us signal on the main board and which ones don't. That one gives us a bit of signal as well. And pin 4. So they're all about the same so far. Okay, that one's nothing. Right, so it's going to be probably, let's just try pin 5. Pin 5 had audio on it, but then nothing seemed to be on it. Okay, no, pin 5 is nothing. So I'm going to start off by whacking it in pin 4 over here and connecting the signal to it. I'm going to turn the signal level up a little bit and see if we can just get that same kind of clipping behavior that we saw with the daughter board fitted. Okay, so no, see here we actually get some reasonable output. Like we're not clipping like we were before. Okay, so we were clipping at about 2 volts before. So let's try and find that issue. If we don't ever clip at 2 volts, and it might just be the issues on the daughter board. But I don't think so, because all of the waveforms coming out the daughter board look pretty perfect. No, that looks good as well. It might be that these pins need the same signal on 2 of them in order to come through an op-amp. Do you know what I mean? So yeah, I'm not seeing the same behavior. But there's none of the clipping issue. None of the waveforms from the daughter board create that clipping issue. See this? That's the problem I've got. But none of the waveforms from the daughter board cause this. They all look really, really super clean. Oh no, they do clip off. Okay, they do clip off. So the issue's got to be after the daughter board, because see that's a pretty big amplitude sine wave. That's a 9 volt RMS sine wave on there. Actually, that's not even clipping there. So the issue is definitely on the main board. This isn't a full bridge. This is a half bridge. This is the driver for the output side. This is the power supply PWM generation. Is the hat cam going to work? No. Oh, I haven't plugged it in. Helps if I plug it in. So I wondered if it was something to do with the base remote. So the base remote connector is kind of damaged here. I'm wondering if the amp thinks that the base remote is on 0. Do you know what I mean? So obviously when the base remote is plugged in, if the base remote is turned down to minimum, then it'll kind of mute the output of the amplifier. So I'm thinking if that's the case, then maybe it's something in the base remote circuit that's kind of muting the output. Hackam killed your scope ASMR. Yeah, I know, it's a lot more direct of sound, isn't it? So we have big amplitude sine wave here at this capacitor, which is kind of near to the remote base knob circuit. So maybe I just attach a potentiometer to the base remote circuit and just see whether increasing or decreasing the resistance there. No, because if this is the issue, the amp thinks that the base remote is present. When you plug the base remote in, it makes a kind of short, doesn't it, between these pads. You know what I'm going to do actually, just for jokes. I'm just going to desolder, because it looks kind of broken anyway. I'm just kind of going to desolder this base remote connector, just in case it's kind of touching on something and it believes that there's a base remote plugged in. Because if it thinks there's a base remote plugged in but it's not getting any resistance, then it's going to essentially mute the output. Right, so that's those things removed from the circuit. So that's out. So it shouldn't think that there's a base remote connected at all now. Not that it should have done in the first place, but right, now let's power it up and let's plug the Class D side back in as well. Let's see what's on the output of the amplifier now. No, it's still exactly the same, so that hasn't done anything. But it would make sense if the amp believes that there's a base remote plugged in and the base remote is turned all the way down. This is the kind of behavior that we'd get, you know? So I'm wondering if there's any parts or whatever that we can remove from the base remote circuit just to kind of rule that out. So a base remote would connect in here. So what do these things connect to? Anything? I imagine this is a DC voltage reference. I think we probably need to pull a voltage to ground. I've tried removing this Q242, see if that does anything. So we have some vias, have this diode. Could it be the other way around, that unplugging the connector would make a connection that's now missing? That is, again, a very, very good suggestion. That is a very good suggestion. So let's see. How even did this go? This one here was at the back. Okay. And this one, I can't remember which order these were in. I think that one may have been there. Yeah, that is a very good suggestion there, my friend, as well. So maybe I should try shorting out some of the connections there. Come in there like that, maybe. Yeah, let's try shorting out a couple of these connections here. So when this is powered up, what do we get? Okay, so we get a little bit of PWM almost weirdly on that one. So we have negative 14 there and 11.75 there and nothing on here. Let me just show you this. So this is nothing. This is 11.75 and this is negative 14 with like some stuff moving around on it. So it kind of says to me that this front one would be the one that gets pulled somewhere to ground or otherwise. None of them connect to ground. We have a diode on this one. Yeah, I'm tempted to try a potentiometer across like some of these. But yeah, not really sure where it should connect or disconnect to. I don't know if this front one should connect to ground or should connect to this 11.7. I don't know which of these is high impedance and which of them is low impedance. I don't know if this back connector doesn't seem to be ground. It's sitting at 0 volts. It's sitting at nothing. Right, let's just try and reconstruct this a little bit. Let's just try and reconstruct this a little bit to try and work out how maybe it might have made a connection. Okay, well this back one actually doesn't seem to have, no, this back one doesn't have any traces on it anywhere. So I'm just going to short out these two. I've got a feeling I tried this already though, actually. I've got a feeling I tried this already and it didn't do anything. Let me short out these two and see what happens. Maybe I didn't try this. I feel like I tried this. So I've shorted out those two, right? So let me see what is it doing. No. So that appears to have completely muted the output entirely now. So do have class D switching. Yes. Yes, we have class D switching. We have 56 Hertz going in. Just put these all to the correct mode. So we have master. Yep, master. Phase. Full. Subsonic. And bass boost and gain. Okay, so now that has like fully muted the output. Now I have absolutely nothing, you see? Yeah. So now I have absolutely nothing there. Whereas if I now desolder that, and power it up and see what we have. Now we have that little sine wave again. So yeah, it's not that. Shorting it would be like having the jack plugged in. It seems that when the jack isn't plugged in, it's open circuit. When the jack is plugged in, the more you pull the signal to ground, the more it attenuates the signal, which we can just confirm with a potentiometer. At this point, I'd probably just backtrack from the Class D module. So that's what I did as well. And that's why that chip was removed from the very first chip that I put back in. I think it goes to there. And then the problem is it kind of splits off into various different chips and stuff. So I was struggling to kind of follow it. But yeah, so if we backtrack from the Class D, so if we just confirm what goes into the Class D module, you can see here, if I zoom in, so it's powered up. So into the Class D, we've got a little sine wave on this pin here. Nothing. A little sine wave on this pin here as well. Nothing. So actually, if I remove the Class D module, we can see what has a sine wave on it from the preamp board. Okay. So let's remove that. And then let's see what has a sine wave on it. Because that'll then obviously tell us what's coming from where. So not that one. Okay, so it's looking like the third pin down here. Okay. Yeah, so it's the third one here. Okay, so remove this, stick a little thing in here. So from the Class D side, it comes in there, and it goes to, we have, it's probably is going to be high voltage, so it's just going to, I think from memory it goes there, third one, via this via, and this via, and then that goes all the way down here. Just got to find where it pops up. Where do you pop up? Okay, you go down to here, so we go into this big ass capacitor, this one, and then we go other side of that capacitor goes into so that's a DC blocking cap, and then that DC blocking cap goes to here. Okay, so this trace here, right? So we're looking at this resistor right here, which you can see I've already kind of removed once. So R163. A schematic actually would be so bloody useful for this. Yeah. So yeah, we're here, and then from this resistor we go into R156. But I've probed all of this op amp and stuff, and some of these have high amplitude sine wave, some of them don't. That appears to have ground on it, maybe? This is where we plug in this board again. Let's bend that so we can see what we are doing. Okay, so that's about as bent up as we're going to get. Okay, so we can take this, plug the RCA in. We've got a nice big output. And then we can have a look in here and probe some bits and bobs. Okay, so it goes through one of these little film capacitors. It'd be nice if it focused. Through one of these film capacitors, and then it goes into this resistor here, R163. So let's just turn it on and have a look at the waveform on there. I've got the signal cranked up really high. Okay, so the signal on the signal generator is cranked up really high, the gain's turned up pretty high, so we should have really high amplitude sine waves in and around the preamp circuit as a result of that. Okay, I need to reconnect my remote wire, which has fallen off. So I currently don't have any header extenders at the moment, but yes, that would be very handy. Definitely would be very handy in a situation like this. Okay, so we have very low amplitude signal on that resistor, and that's part of our problem. You see? Very low amplitude. That's supposed to be very high amplitude. If we look over at some other parts of the circuit, very low amplitude. This op amp has all very low amplitude sine waves on it. And I'm just going to go either side of some of these film capacitors as well. Just check the signal either side of them, just to make sure it's not high on one side and low on the other. High, high, nothing. Low, nothing. Low, now this 104J100, this blue capacitor here, this has a little bit of signal on one side and nothing on the other. Now, is that supposed to have nothing on the other? Is it ground on the other perhaps? Let's have a look. Possibly, yes. Any other film caps? Can't see any other film caps anywhere. All the other signal film caps have high amplitude on one side and high amplitude on the other. This op amp has low amplitude on all of its pins. This capacitor has low amplitude. See, I'm wondering whether this 13600 is bad. That's why I removed it, to check whether it might be bad. Because we have some like little bit of DC on like some of the outputs. See here, pin 1 we have sort of 1.8 volts with this weird waveform on it, and we have like some random bits of DC with the signal floating on it. So I'm wondering whether this is the problem, this 13600. But the thing is that this 13600, it doesn't seem to ever have the high amplitude sine wave coming into it. There's something really weird going on one of the pins. See, this is what's on one of the pins. Two of the pins actually. So yeah, there's no high amplitude waveform going into the 13600. So it's not like it's getting the full signal in and then just not outputting the correct signal. It's just not getting it in the first place at all. So that's what leads me to believe that the issue is somewhere else. Have you checked the voltages at the op amps? Yes, of course. Yes. See, here we have a high amplitude sine wave, and then it goes to where exactly? That's DC. That's something to do with the base remote. There's a high amplitude sine wave on this op amp. So this op amp is probably working correctly. Yes, I know I'm only feeding signal into one channel. That's nothing to do with the issue here. I'm just going to start checking random resistor values around here, to be fair. 103, 203, 203. Yeah, I really have genuinely no idea what the problem could be. Proper random, no idea. And maybe we could find it, but I feel like it would just take forever to try and find the problem here. It's kind of giving off those vibes that it's a bad via or a broken trace or something somewhere. So yeah, not really too sure what to do about this one, if I'm honest. Like, it should be so simple, but it's not, and it makes it so much harder not, you know, having this in the way. You can't really probe everything properly. It still feels like a problem with the remote bass knob circuit. It feels like a problem with that circuit, the kind of way that it would attenuate the signal like that. That's what it feels like anyway. But yeah, not really sure where to start looking on that. That's at -14. So when we short those two out, what does the voltage become? Which one is it that matches the other? So this middle one goes and matches the one at the bottom. Okay. So that causes a bit of DC. Yeah, barrel connector bass knob plugged into that one. Barrel. What's interesting is that the amplitude of the little sine wave going into the output driver card doesn't change with frequency like it does when we have the output board connected and the Class D board connected. See that? That's the same amplitude all the way from 18 Hertz all the way to 200 Hertz. It's the same amplitude going into the driver card, but it does change in amplitude when we have the Class D switching actually going. Is it maybe a feedback thing? Like, I'm not aware that Class D circuits really have feedback into the preamp circuit. It also doesn't change with that base remote being shorted. Yeah, it does. So with the base remote being shorted, we get no output. So the base remote being shorted results in amplifier muting. This is an XTR 2500, I think. But yeah, really not sure what the problem is here. I might just end up just bypassing whatever part of the preamp is causing this issue, and just yeah, tying that in to the Class D drive circuit. I think that's going to be the best option. So if we can just find somewhere, if we can find a position on the preamp board where the RCA signal is affected by preamp, by the low pass filter and everything, then we can just connect that to the input to the Class D board and just call it a day. I think that's going to be the best option. So let's go. We've got signal going in. I've switched this to 24 dB roll off on the low pass filter. Subsonic is on. I'm going to turn subsonic on as well. Low pass filter. Let's just turn these ones down. Gain is down. So when I find one that is affected by gain and the bass boost and the low pass filter. Okay. Okay, so we've got signal just over here, 500 millivolts. If I turn the gain up a bit, we go to 1 volt. Okay, so it's affected by gain. Is it affected by low pass filter? So we've got currently got 580. Turn the low pass filter up, 6, and turn it down all the way. Okay, yeah, that's definitely affected by the low pass filter. Those are the most important ones in my opinion anyway. Subsonic filter. Let's turn that all the way down, like 17. Yeah, that's affected by subsonic as well. So I think one of the best places is probably going to be over here. That seems to be affected by everything. So R240. So if I make a little connection from R240 and bring it over to Alright, there we go, R240, and we're going to bring it all the way over to this resistor here, R163, which is where it kind of gets sent into the drive circuit, right? So let's make a little snip. Let's make a little snip here. Alright, so now if we place the preamp card and the output drive card back in place, we can see what kind of sensitivity the gain and everything is, because obviously we don't know, we've taken that signal from a random place, so we don't know how it will affect the kind of gain sensitivity of the amp at this point. We don't even know if it will be happy being sent to the output driver card anyway, but let's just see. So we've got everything connected back up. Signals, turn that down a little bit, turn the frequency up to like 33. Let's turn that to 24 dB roll off. Let's turn that up to a little bit, turn the gain down, bass boost down, phase. Okay, let's see what we get. Okay, so we have some signal there. So this is with the gain on minimum. Okay, so with the gain on minimum, we have output. So if we increase the gain, got some output there. Yeah, that's kind of behaving like the sensitivity, very similar to other amplifiers. So do we reach rail clip point? Yeah, we do. There's rail clip point. Cool. And this is all affected by the low pass filter, etc. Yeah, so I think we'll just leave it there. Leave it at that. It is functioning now. It's working just fine. Does the phase work? Yeah, the phase works. So yeah, I think we literally just leave it there. Whatever the problem was on the preamp board, no idea, but yeah, finding and taking a signal source from somewhere that is affected by all of the preamp controls, I mean, no one's going to know. I don't know what functions or behavior we have bypassed there, but something has changed. Something that we've bypassed something, but the amp is definitely working now. So I think we'll just leave it at that. And I think, gents, we'll leave it there for the stream as well. It's been a nice little afternoon, 3 and a bit hours. Done a few bits. I was kind of just messing around today, just looking at things that I had, not doing anything too serious, taking my time. So thanks so much for all your suggestions and keeping me company in the workshop. It's been really cool. Yeah, maybe see you a bit later over the weekend or next week. So thanks for joining. Have a great rest of your day. Have a great weekend if I don't see you, and I'll see you next time.